Welcome to Split Lesson 50 for the 6th grade today. We're going to continue exploring fractions, and specifically we want to start to understand the process that goes into dividing fractions. But before we get into that, we want to take a quick review of looking at mixed numbers, and especially looking at mixed numbers as our number lines increase and the different type of fractions that So the number line that we're looking at here has intervals of going from 0 to 1, and we see, if you count the spaces, you would see very quickly that there are 10 spaces there. All right? So once we know the number of spaces, then we can start counting. Count 1, 2, 3, 4, 5, 6, 7, and of course, since there are 10 spaces, our fraction is 7/10. Looking down at the bottom, now at the start, our spacing is once again 10. If you don't believe me, go ahead and count. All right, and so we can start counting then. 1, 2, 3, 4, 5. And so we have starting at 3, and now we add 5/10. Right, 5 out of the 10. Right, and of course you'd see this and say, okay, I need to reduce this to 1, 3.5. Right. Looking at our last idea, the smiley face. Right, we're starting at 4. And we didn't quite make it to 5, so we want to understand these fractional ideas. Right. Once again, still 10 spaces. Count 1, 2, 3, 4, 5, 6, 7, 8 lines. So there's 8 out of the 10. Once again, you're going to say, hey, that needs to be reduced to even numbers. Right. 8 is even, 10 is even, so that can be reduced. And so we're going to reduce and get an answer of 4. That should be pretty basically looking at that idea that we've talked about already this year. Then, moving on to some new ideas. As we look at the new ideas, we want to, first of all, do something very, very simple to help us understand why we're able to do what we do in the future. All right? So, first idea is how much of $1 is a quarter? Right? Write that as a decimal and a fraction. Right? So, if I have 25 cents, I want to understand what the decimal of that looks like, and I want to understand what the fraction of that looks like. 25 cents out of 100 cents is how we get $1. Right? So now we have a fraction set up. And right here, our fraction says 25 hundredths. So I can rewrite that in decimal form as 25 hundredths. And of course, we know that very simply because of this idea. And of course, what fraction is represented there? And that would be 1/4. Pretty basic idea that we've looked at many, many times, probably from the start of looking at fractions. But now we're going to take this idea and try to understand, well, how many quarters are in $3? Here's where we can start to use this idea. If I have $3 and I want to know how many quarters are in $3, what I'm doing is I'm going to divide by a quarter. In this case, we're going to use the fraction so we can start to see the relationship. Now, if I'm going to divide by a quarter, what's going to be important to me is first to understand, well, how many quarters are in just one single dollar, all right, or just in one. And of course, you know that in $1 there are 4 quarters. So 1 divided by a quarter is 4. So we have that idea. From here, then, we can apply this idea, right? If there are 4 quarters in $1, then in the end, I'm going to take my $3 and multiply by 4, right? Because there's 4 in 1, so now I want 3 times 4 to figure out how many quarters are in $3, and I'm going to get an answer of 12 quarters. And while it's a very simple step process, we see a relationship that can exist between this idea right here and this idea right here. And I'll give you a clue. It starts with an R. And I'll let you think about it as we go with our next example, because it's going to be important to understand exactly what just happened. What is that R? Next example says, if a nickel is 3/4 of an inch in diameter, how many nickels would fit in a line that is 6 inches long? Now, you could draw out a line 6 inches long, and you could start taking your nickels, and you could place them on this, oops, that was supposed to happen, on this line. And as you do that, you could say, okay, here I go. I'm putting my nickels down, and quickly you're going to see that there are, my spacing probably isn't that good, probably doesn't quite line up with my line. Okay, just my line. But in average, as you look at this, there should be about 8 nickels that would fit in a line that's 6 inches long, especially if it's 3/4 of an inch. Okay, that's what our picture shows. However, we can do this using division. We're going to take our 6-inch line, and we're going to divide by 3/4. And we're going to look to get an answer. Now, to understand this best, the best thing to do is, well, if I can tell you how many nickels fit in 1 inch, right? If I have 1 inch, and I can tell you how many nickels fit there, then I should very easily be able to figure out how many nickels are in 6 inches. Okay? So 1 divided by 3/4. So we kind of looked at this idea already when we were studying reciprocals. We learned that a fraction times another fraction equals 1. Which, of course, as you look at this idea, and this idea really is just the reverse, right? I'm actually, to solve this answer, technically I'm dividing by 3/4 to get this answer. Okay? We look at the properties, the principles of flipping things around to help us solve. Now, we've looked at this idea, and to get this to equal 1, we're going to take 3 times 4, get 12 over, and then 4 times 3, so that's going to be 12 over 12, which is equal to 1. And we call that, of course, that R word would be reciprocal. And so 1 divided by 3/4, of course, we just 4/3. Or basically, it's the reciprocal of 1. But now that we have solved for the reciprocal, we can take this idea and we can apply it. And we can say, well, if in 1 inch is 4/3, then 6 times 4/3 should get me the answer of nickels that can be found in this 6-inch line. Our picture is showing us 8, so we're looking for 8 in this idea. I'm going to erase this so we can have this idea represented so we can easily see how we're multiplying numerator times numerator, which of course is going to give us a 24, and denominator by denominator, which is going to give us a 3, and 24 divided by 3 equals 8. So there should be 8. Okay. And of course, as we look up at the picture, I'm sure if we were to space things out, right, we got some overlapping taking place right here, a couple other places. I think if we were to get it all evenly spaced the right way, we would see that, yes, 8 nickels fit on this 6-inch line. So in the end, as we look at this process, what really happened was we took a number, a whole number, and we're dividing by a fraction. But to actually solve this, what we ended up doing was taking this whole number, right, and we multiplied by its reciprocal. And we got our final answer. So as we explain how to divide by a fraction, what we're really going to do is we're going to multiply by the reciprocal. Right? We're not changing this number, we're changing this number. Right? This 3/4. Instead of dividing, we're going to multiply. Instead of multiplying just by the actual fraction, we're going to flip it, make it a reciprocal, and we're going to get our answer. So to divide by a fraction is to multiply by the reciprocal. So following the steps will help you solve these problems. So that's our look at, first of all, that quick review on mixed numbers on a number line. Dealing with tens now. And here's a sample problem to help you work with dividing by a fraction. That is lesson 6.